Have you ever felt like building an AI application was just a total mess? Like you're wrestling with this tangled knot of code and you're not sure which way is up? Well, you are definitely not alone. But what if there was a better way? A new language that could take all that complexity and turn it into these elegant, powerful, and frankly, beautiful chains of logic. Today, we're diving into that exact shift, and it's called LangChain Expression Language, or as we'll be calling it, LCEL.
And this really gets us to the core question, doesn't it? It feels like almost overnight, engineering these really sophisticated AI apps went from this kind of chaotic dark art to a streamlined professional science. So what happened? How did we get here so fast? To get to the bottom of it, we're going to break it down into 4 parts. First, we'll look at the tangled code problem, what things were like before. Then, we'll see how LCEL offers a much simpler language. After that, we'll explore how it's engineered for serious performance. And finally, we'll see how it all comes together in a package that's ready for the real world. Let's start with the problem.
You know, to really get why a solution is so great, you first have to appreciate just how messy the problem was. So let's take a quick look at the before picture, what building an AI app felt like before LCEL really hit the scene.
This quote, it really nails the challenge. Developers needed expressive composition, right? The freedom to build really creative, complex apps. But the old way of doing things often created these fragile, over-engineered contraptions of code. And uncompromising performance was the goal, sure, but the reality was often slow and clunky. And observability? Forget about it. Trying to figure out what was happening inside that tangle was almost impossible.
This comparison really just lays it all out. On the left, you've got the old way, nested, imperative code, basically spaghetti code. That was a total nightmare to debug. If you wanted things to run at the same time, you had to handle that parallelism manually. Tracing was an afterthought. But look at the LCL side. It's a whole new world. Declarative, modular, easy to read. Parallelism, automatic. Deep tracing and observability, built right in from the ground up, is truly a night and day difference.
And that brings us to the solution itself, the thing that finally untangled all that code. So let's get into what actually makes LCL so different and, frankly, so powerful.
The absolute heart of LCEL is its declarative syntax. So what on earth does that mean? Well, instead of writing a bunch of code telling the computer how to connect every little piece step by step, you just declare what you want to connect. The best analogy is Lego bricks. Each component in your AI, the prompt, the model, a tool, is a single Lego brick. And they're all designed to just snap together perfectly, without you having to engineer the little plastic bumps yourself.
Just look at this. This one line of code is a complete functioning AI chain. The magic is right there in that little vertical line, the pipe operator. Now, for developers, this is a super familiar idea from working in the command line, but here, it's the snap that connects our Lego bricks. It creates this beautiful, clean, left-to-right flow that's just so easy to read and understand. You take a prompt, you pipe it to a language model, and you pipe that result to a parser. It's that simple. It's that elegant.
So you might be wondering, how do all these different Lego bricks know how to connect so perfectly? Well, that's the secret sauce, and it's called the Runnable interface. You can think of it like a universal adapter, maybe like USB-C for AI components. Every single piece, whether it's a prompt, a model, a custom tool you build, it's all built with the same standard interface. And that guarantees they can all speak the same language and connect together just seamlessly.
Okay, so we've established that LCL makes our code way cleaner, way more intuitive. But for real-world, professional applications, being pretty isn't enough. It has to be fast, and it has to be able to scale. So let's dig into how LCL is engineered for performance right out of the box. One of the most critical features is that every single LCEL chain is automatically asynchronous. What that means is it can juggle multiple tasks at once without having to wait for each one to finish. For a web app that has thousands of users hitting it at the same time, this is an absolute game changer. It's the difference between a snappy, responsive app and one that just grinds to a halt under pressure. And with LCEL, this isn't some add-on you have to bolt on later. It's a core, guaranteed feature.
LOSCL also makes it incredibly simple to run tasks in parallel. There's this component called RunnableParallel, and it uses a pattern known as fan-out, fan-in. So imagine a user asks a question. The system can fan out that question to a database, an API with user info, and a prompt generator all at the exact same time. Then it fans in, gathering all those results together to build the final answer. This slashes the time a user spends just staring at a loading screen.
And finally, let's talk about user experience. LCL is heavily optimized for something called time to first token, or TTFT.
The whole idea is to get the very first word, the first piece of the answer, back to the user as fast as humanly possible. Think of it like a barista who starts pouring your coffee and immediately slides the cup over to you. You can start sipping while the rest of the cup fills up. It makes the entire application feel so much more responsive, even if the complete answer takes a couple of seconds to generate.
Now, writing the code is really just one part of the puzzle, right? A truly professional tool needs a whole ecosystem around it for deployment, for monitoring, for debugging. And LCEL is the foundation of exactly that.
So it all starts here, with the foundation, LCEL itself. This is the core language we've been talking about, the tool that lets you build your application's logic in that clean, readable, and performant way. Okay, but how do you actually get that logic out to the world? That's where LangServe comes in. With just a handful of lines of code, LangServe takes your LCEL chain and wraps it up in a production-ready API. It handles the web server, the data validation. Basically, all the boring and difficult parts of deployment are just handled for you.
And then, once your app is live, you need to be able to see what's going on. LangSmith is the final piece of this ecosystem. Think of it as your mission control center. It gives you X-ray vision into every single step of every chain run. Because of that standardized tracing that's built into LLCL, you can easily hunt down bugs, track performance, and keep an eye on your costs.
So when you zoom out, what's the big picture here? Well, adopting this whole ecosystem is a massive strategic win for any team. It means less complex code, which is way easier and cheaper to maintain. It means your architecture is ready for the future. It means you're accumulating less technical debt. And, hugely important, it means new developers can get up to speed so much faster. These are real, bottom-line benefits.
And that really brings us to our final thought. For so long, AI engineers have spent the majority of their time and brainpower just wrestling with the plumbing, the infrastructure. By making that part simple, clean, and standardized, LCL frees up all of that creative energy to focus on what actually matters, building the next generation of truly groundbreaking AI. The question isn't how we build anymore. The question is, now that the hard part is easy, what can we imagine?